Welcome to this first edition of the Alephium Tech Talk Cross Open Office. This is not our first event on Discord, but it's the first time we run this format. So we're really eager to get your feedback, as usual. And the concept is really simple. First, we have a tech talk, and after that, you will be able to ask questions about the talk and exchange with the team in live and direct. And today's talk is titled From Bitcoin to Alephium, and it will be presented by Hongchao. Hongchao is currently based in Sweden, and he's been very interested in Bitcoin since 2015, and also a very experienced core contributor to Alephium, basically like a core developer, right? And I've never had the chance to hear him do a talk, but I've had the chance to entertain some concepts with him, and it's been extremely rewarding. So I'm very keen on this talk. Basically, before we get to the essence and let Hongchao do his presentation, I would just like to let you know that the Alephium team will be in Paris for the FCC from the 18th to the 21st of July, where Cheng will give a talk. And well, if you plan to be around and you want to check us up, or you want to have a drink and a chat, even if you don't have a ticket for the festival, well, you're very welcome to let us know. And you can do so on Discord, Twitter, Telegram, or whatever channel you're most comfortable with. So, well, without further ado, if Hongchao, if you're ready, the floor is yours.
Yeah, nice. All right, thanks, Seth, for the nice introduction. My name is Hongchao. I'm one of the core contributors of the project. Today, the topic of my presentation is called From Bitcoin to Alephium. So basically, my plan today is to first off talk a little bit about blockchain in general, and then we move on to Bitcoin, talking about some of the core concepts of Bitcoin, for example, proof of work, TTxOO models, different transaction data model, and even some of the smart contract capabilities of Bitcoin. And then we're going to talk about the limitations, and some might argue it's also its strength of the Bitcoin system, and some of the attempts that the Alephium system have made to basically address some of the limitations of the Bitcoin-like system, such as scalability and energy consumption, and also the smart contract capabilities. So let's start. So blockchain. I think one of the very sort of fascinating thing about blockchain is the fact that it's very multidisciplinary, and many people come into the space for different reasons, and some come because of the ideological reasons, and many of them are, they care a lot about self-sovereignty, and they oftentimes have like libertarian kind of background, the anti-establishment. In fact, Bitcoin probably can be seen as a protest to, some perceived unfairness, like in the banking system and so on, right? So there are also people come into the space because of financial reasons. They just want an alternative way to basically transact or preserve their wealth, or I don't know, like speculate and things like that. And many of us come to the space because of technology, and we care about writing programs that is not stoppable. We talk about things like consensus algorithms and sharding and different kind of layer 2s and bridges and things like that, zero knowledge and blah blah blah. But there are also people who don't give a shit about all these things, and they just want to use to see like what kind of use cases can blockchain technology enable, basically, like NFTs and DAOs and Web3 and so things like that. But if you kind of use one word to describe what blockchain brings onto the table, I would probably argue that it's trust. Because prior to Bitcoin and blockchain, we never had a machine which is not controlled by someone else. that can actually constantly output trusts. That didn't exist before. So trust becomes like a spectrum now. Previously it's not. So now it becomes a spectrum ranging from a very centralized kind of trust, which is like a bank, to a very decentralized kind of trust, which is kind of a Bitcoin, and everything else in between. And I think this is a very important thing to understand, because this creates a lot of design space, like a trade-off space for all the like solutions that we have in the space. For example, if we talk about scalability, does that actually sacrifice? Where does the trust sit in this kind of a spectrum of centralization and decentralization? It's very interesting things to discuss, and we would like to believe that the solution that Alephium, like scalability solution that Alephium proposed, doesn't actually sacrifice that kind of a trust. Okay, so now let's move on to Bitcoin. And if blockchain is all about trust, right, solving trust problems, what kind of a trust problem does Bitcoin solve? I think probably one of the most important one is the double spend problem, which is basically like in this decentralized or like distributed network of nodes. In this kind of a system, how would you make sure that your coin is not double spent? I think this Bitcoin is probably the first like Bitcoin is the first system to actually solve this problem. So for that, it has its historical significance. And the way that it solved it is by using something called Nakamoto consensus, which is a combination of proof of work plus a set of rules. So proof of work basically brings two things onto the table. One is that it's extremely expensive to do. So that means that if you want to rewrite histories and so on, it's very expensive. Number two, it actually brings distributed kind of randomness into the system. Because in this distributed kind of a network, we need to select who is the next block proposer. And that process is kind of random, of course, based on the hash rate and so on. But this provides the kind of a randomness into the system. And also the rules, like we need to have some kind of a rule to make sure that the chain grows. One of the rules is that basically the chain that has the cumulative, the heaviest or the most accumulative compute power, like the costs, the heaviest chain basically wins. And that's one rule. And another rule is very simple: coins cannot be spent twice. I think this is it sounds very simple, but it's actually pretty profound, because in order to do that, you would have to kind of know every single coin in the system from the beginning of time and all the history associated with these coins. And I think we will revisit this like later on in the talk, when we talk about how Alephium basically prevents double spends. But I think this is a very it's not as simple as it sounds actually. And then, yeah, Bitcoin also has a very strong social layer, and this is what makes Bitcoin Bitcoin. It's very, very difficult to actually make changes to the system. So now we're going to talk about some of the key concepts in Bitcoin, and I think this is very important, not just because this is valid in Bitcoin, but also because this is to a very large extent valid for Alephium as well. So if you don't take sharding into consideration, all these concepts actually applies to Alephium too. So essentially we have blocks, and we have a set of transactions in the block. And then through proof of work, which, as we discussed before, is some kind of it actually provides distributed randomness to the system. It actually picked a winner or a block proposer, pick the block and add it into the blockchain, right? So after the block is added to the blockchain, it updates something called UTXO sets. And UTXO sets, as the name suggests, contains sets of UTXOs. And UTXO can be thought of as some kind of a coin, some coin that is locked up in a safe, which you have to basically unlock to be able to spend it. So it's some kind of a coin locked up in the safe. And of course, in your wallet, you know how to unlock it, right? Otherwise, you can't spend it. And the wallet basically queries the UTXO set to see how many coins it is able to unlock. It has the potential to unlock, and in that way, it basically like calculates, add the sum up together of all the coins and calculate the final balance of your account, right? So this is basically how, in the high level, how like some of the key concepts in Bitcoin, which is also valid in Alephium, and you can see clear heritage of these concepts in Alephium code base as well. If you dive a little bit deeper into the transaction, you have a transaction basically spends like unlock coins from a safe and then put it into another safe, which is locked by some other lock, right? And through this process, it actually transfers ownership, because if you unlock a coin and put it into another safe, which is locked by another lock, it cannot be unlocked by you anymore. It's probably can be unlocked by someone else. So through this process, it transfers the ownership. And if you look at this graph, this basically illustrates how the process looks like. You have a safe, and you have coins, and you unlock it, and then you lock it again. In the transaction, you basically unlock and lock. And I think one of the very interesting things during this process is that the lock is actually programmable. So it's not like just a mechanical kind of a lock and a key. It's basically a programmable kind of lock. You can basically lock this safe in such a way that like only like 3 out of 5 people like in 5 years can unlock it, something like that. So you can have some kind of a logic here. And this is done by a programming language called Bitcoin script, which is kind of like a smart contract programming language in Bitcoin. And I think, so that's a very interesting thing, and it's very limited. It's stack-based and so on, but still, people manage to do interesting things about it. For example, like Lightning Network is something that it uses the Bitcoin script to actually do some of the logic there. So how does it look like? So this is actually a very, very typical Bitcoin like locking and unlocking scripts of a very typical Bitcoin transaction. And the one on the right-hand side is a locking script, and the one on the left-hand side is the unlocking script. So the lock to the safe and the key to the safe. Basically what it does is that, okay, on the unlocking you have a signature and public key. On the locking script you duplicate the public key, you hash it, you compare, this is equal, right? You compare these 2 hashes, and then you do a verify sig. That's how it works. Okay, we have talked a lot about Bitcoin. I think, it's I can understand it's kind of weird, but I think so I'm going to do a demo now. I think hopefully, like after the demo, you will have a much better understanding of how it looks, both the transaction data model and also the scripts and so on. So I guess all of you guys know this famous transaction that people spend 10K Bitcoin to buy a pizza and so on, right? That transaction is very famous. So we're going to look at how that transaction looks like. We use this website to illustrate how it looks like. So we can search this. Okay, can you actually see it's clear, right? So this is the famous transaction where people spend 10K Bitcoin for the pizza, and you can see it's a very large transaction as well. This is how it looks like in the wire, in the hex format, very big, and you have a lot of inputs. So this is paying from, these are the inputs. You can see that there are inputs with 150 and small ones as well. But if you scroll all the way down, you'll be able to see that in the end it spends 10K Bitcoin to this very lucky address, right? This address is a 10K Bitcoin. Not sure what's the balance now. But you can see that this is the locking script. If you remember, the previous slide, exactly the same as this, right? You have dup, hash, blah, blah. Exactly the same. This is not the same, and all the unlocking scripts of the input, they are exactly the same as this as well. It's a sig and public key. It's a signature and public key, basically. So looking at this transaction, you'll be able to see that you have a very many like inputs. The total value is probably close to like 10k. It's probably 10k BTC, and you have one output, which basically lock it up into another lock. That's the whole thing. But if you want to see, for example, how this 400 Bitcoin is spent, you can basically click interpret, and then you'll be able to see that it concatenates the previous lock and also the signature and public key and so on. It just execute this thing one by one by just evaluating the opcode. In the end, it will basically check the signature of these two things, and then it checks, and then it's successful. That's basically how Bitcoin transaction works. Great. So hopefully we have better understanding about the Bitcoin transaction data model and the Bitcoin scripts a little bit more. Actually, you can actually write more sophisticated Bitcoin smart contracts using Bitcoin script, but as you can imagine, this is very complicated because all these things are opcodes and it has to be pushed to the stack and so on. So this is, for programmers, it's a nightmare, and I have a great admiration for people actually work on Bitcoin scripts like this. All right, so strength and weakness. I think it's, the scalability of the Bitcoin, like we have like 7 transactions per second, and we have only one chain, there's no charts. That's one thing. We have very weak smart contracts capability, as we illustrated before, and the energy consumption is equivalent to Sweden, things like that, right? But people also argue that these weaknesses are its strengths as well. For example, like the weak smart contract capabilities, the fact that you can't really, you have a very weak programming language means that you can't really program sophisticated like applications, which means that it's very difficult to do MEVs and so on the blockchain, on the Bitcoin blockchain, which probably makes Bitcoin a much harder or stronger currency. So it depends on your kind of perspective, right? So enough about Bitcoin. So let's talk about Alephium. So when it comes to scale, so we're going to talk about 3 things. One is the block flow, which is kind of a sharding solution on top of the, like some of the stuff that we talked about, the core concepts in Bitcoin. We're going to talk a little bit, just briefly, about proof of less work. Also, we're going to talk about the smart contracts, the programming language, and the VM that we introduced in Alephium, which is much more expressive and easier to work with compared to Bitcoin scripts. So first off, block flow. So the general idea is that we're going to divide the system into G groups. In this case, let's make it more concrete. Let's say like 3 groups, as illustrated here. We have A, B, and C. Then we have 9 chains or shards. Let's use, we can use that interchangeably, I think. So like 9 G minus multiply G, 3 is 9, right? So you have A to B, B to A to A. Like as you can see here, there's 9 chains, right? And we have 1 UTXO set per group. So we have 3 UTXO set here instead of 1, which is in Bitcoin, right? We have 3. And for each of the group here, it needs to care about 2G minus 1 shards. Why? Because for B, it only needs to care about all the chains that interacts with B. For example, A to B, B to A, B to C. So like in this case, it's 5. So because G is 3 and this is 5. And the interesting thing is that it doesn't need to care about anything that is on A to A to C to C, or AB and AC and CA. That's actually where we get the scalability, because it's probably not very clear, like with G is like very small as 3, but if you have like G equals 10, we would have like 100 chains or 100 shards in the system, and one of the node needs only care about like 19 shards or 19 chains. That's kind of a like nice thing to have. And because we have like TTxOO sets, like the clones in each of the group, So let's go back. So like remember, like when we talk about the Bitcoin, we said that in order to prevent double spends, we need to kind of be aware of all the coins in the system and its history and from the beginning of time and so on, right? So you need to be aware of the full picture of this coin to be able to not double spend it. And in order to because UTXO now it's not like only one copy, it's like 3 copies in this case. So in order to have a holistic view of this coin, we need to kind of know all the chains that can potentially influence this coin, right? So in this case, for B, it would be like A, B, B, A. So it's like these 5 chains. So basically, if we want to build a block on a chain that spends a coin in this UTXO set, we need to kind of establish some sort of dependencies for all these 5 chains. Then you have a holistic view of what could possibly influence this coin. Then you can reasonably say that I haven't double spent this thing, right? So that's kind of the idea of like for each of the block that is added here, you need to kind of refer to all the blocks on the other 5 chains as dependency, if that makes sense. So yeah. And one interesting observation is that if you reduce G to 1, right, it becomes Bitcoin. If you have G to 1, then you have one group, and you have one kind of shard, and it becomes Bitcoin, right? So then you have no dependency because you just depend on yourself, which is exactly the same as Bitcoin. You just depend on your previous block, right? So how do we sort of involve the system? Like, if G is 1, then it's kind of, then it's not very interesting because it's Bitcoin. If G becomes 2, which is this case, we have 4 chains, like 1, 2, 3, 4, right? 4 chains. For each of the block here, it would have 3 dependencies because 2 multiplied 2 minus 1, as we see in the previous slide, is 3, right? So we have 3 dependencies, 1, 2, 3 for this. So we have like hashes for this 3 blocks in this block as dependency. And when we mine, we not only consider the cumulative difficulties of this block, but we also consider the difficulties of all the other dependencies as well. So we consider the cumulative weights of everything, including the dependencies, and use that to determine like which chain wins. As opposed, like you can see the sort of the collection. You can think of it as a generalization of block Bitcoins. For choice, basically the one chain that has the highest, the most work wins. That's the basically block flow in the gist, and we talked about, for example, how do we make sure that we don't do double spend. We also talked about where do we get the scalability from. It is the fact that as the G grows, we increase the number of chains, but for each of the nodes, we actually don't have to care about all the data that is not relevant, basically. So currently we have like 4 groups, 16 shards, and the transaction is like up to 400 TPS. And according to some calculation done by chain, we can go up to 32 groups and 1,024 shards with up to 10K TPS compared to other, So that's block flow. And then let's talk very briefly about proof of less work. And the general idea is that we want to, in Bitcoin-like system, we have, everything is done in the physical world. So we consume a lot of energy to do mining and so on. What if we combine the physical work and shift some of the cost to the internal system in the forms of coins? Let's say the idea is that let's say the coin reward is 1 coin. What if the miner decides to take half of a coin instead? Then he probably needs to do less work because he already spent half of the coin if he gets the coin, right? So If he decided to spend half of the coin, then we'll give him a boost. The system will give his the amount of work that he performed physically a little bit of a boost, basically. And this formula, like so if you have like one coin, that is the coin reward. A is like the amount of coin that you want to take. Then basically you get this wave function applied to 1 minus a, which is somewhere between like 0 and 1. You apply this as some kind of extra weight that you give it to the physical, like on top of the physical work it performed. So the hope is that through this you get similar kind of security, because the cost is still there. Like you just spend the coins like instead. It still has a cost associated with the coin, right? In combination with the physical cost. If the cost is kind of similar, then kind of hopefully the security is kind of comparable compared to before, like where everything is done physically. So in that way, you can save some energy, I guess. So if you want to read more, you can read the white paper and this code in like here. I think we will share the presentation a bit later. And there's also a talk by Chen on YouTube. I think it goes extra length on this topic. Okay, let's talk about smart contracts. As you can see here on the right-hand side, this is much nicer than the stack-based Bitcoin scripts, right? And this is more like a program that all of us can do. So yeah, this is an NFT mass marketplace that we sort of experimented recently. So we have our own virtual machine. We have like a programming language called Raf, which you can see from here. We have some nice features. But let's do a demo. We have built a very simple prototype, like an NFT marketplace, using this smart contract. So, okay, this is just the code, but you have some stuff code you can see from here, and you can see that we have some smart contracts that we wrote, like NFT collection, like marketplace, and so on. But we also hosted it somewhere. Yeah. So this is running on some DevNet, so it's you don't even need to kind of sign, but you can kind of sell it, and then you just, and this is what we sold. And then you can probably find, this is 11, right? So you can probably find it. Yes, from here, and then you can buy it and so on. And you can sort of mint a NFT from here. Yeah, I'm not gonna mint anything, but yeah. So we can like we're trying to basically iron out some of the, try to make the developer experience better and try to improve the dev stack. Recently, I think the team are working very hard on that. Yeah, like we will have better documentation and like better libraries and so on, I think fairly soon. Yeah, some of the stuff that we will do, like the dev stack, the bridge, we'll have more simple applications such as like decentralized exchange and like we have mobile wallet and so on. Yeah, these are some of the links. I think that's pretty much all what I wanted to talk about. Thanks.
Amazing, Hongchao. Thanks a lot. Great. So, well, let's just move on to the second part. Like, if anyone has a question, there are a couple of you I had to mute because you didn't close your microphone. So, if you're talking and nobody is reacting, just say something in the chat, maybe. But does anyone have a question for Hongchao?
Yes, Fabian here. Like in the quick demo that you just showed before, we didn't see like you would expect a MetaMask wallet opening or something like that when you buy or sell. Is it like just because it is a demo, or other mechanism?
MetaMask wallet. Are you talking about the MetaMask?
Do you know, like, is it clear now?
Yeah, it's a little bit on and off on my side.
Okay, let me repeat and let me know if that's clear enough.
Yeah.
Like in the demo that you showed before quickly, like you would expect to see your MetaMask wallet opening if you would be on Ethereum or something like that.
Yeah.
But is it that just because it is a demo that you show very quickly that we didn't see any wallet opening, or is it some other undergoing magic?
Yeah, exactly. We have built wallet connect integrations and so on, and it's basically a config. It's a config. If you look at the Alephium NFT repository, there's a config to basically config this application to use the wallet connect. Then you can basically use the desktop wallets that we have right now to sign the transactions and so on. This is basically, as you said, for demo purposes. Yeah.
Okay, thanks.
Anyone else interested in asking Hongchao anything?
I would have another question regarding offline transaction. For Bitcoin, we have the Lightning Network that you can speed up transaction, and then you could do transaction offline as well. Is it something that is on your radar as well for Alephium, or what is the state of the research on that topic?
Are you talking about the layer 2s, or because I guess Lightning Network is layer 2, right? So are you talking about whether we have plans for layer 2? Is that the question?
I wanted to know more about Lightning on the Lightning network. So that's a layer 2. Yes, you can do offline transaction and then come back and synchronize your balance or whatever. Is it maybe? I mean, it was just for curiosity. Is it a topic that you have think about and because I was thinking about development country where they don't have always connection, and that's a use case as well that you can pay offline and then come back and synchronize your wallet, for instance. I don't know if that's clear enough what I have in mind.
Yeah, I think two parts. One is the layer 2. I don't think that's the focus of the team right now, because we are focusing on like scalability on layer 1, and the priority is to basically make the dApp stack much better to attract applications to be built on top of layer 1 first. If that's not enough, then maybe we can think about layer 2. The offline thing, I'm not sure actually. Yeah, I haven't heard anything related to that.
I see Lee is answering a little bit in the chat. I'm not sure it's related, but he says, I mean, it's always possible via Ralph. L2.
Yes, definitely. Like it's just not the focus now. I mean, Bitcoin can support layer 2 with the Bitcoin scripts.
And I think there was a question from Montail in the chat about promoting the NFT marketplace and this I would like to answer. So we, as Alephium, we do intend to run an NFT marketplace, right? We are just building the tech stack for other people to being able to create NFT marketplace and then build on Alephium. But to make sure that we have everything needed, we of course need to build our own, but we're not going to be making our own and promoting it and things like this. Yeah, so I guess that's to answer on the chat.
It looks like Montail was satisfied with the answer.
Well, maybe if no one has anything to say, I, want to take this opportunity maybe to remind the people that are here that we have a reward and grant program for people to contribute to the ecosystem and start building on Alephium. Obviously now, specifically with the work that Hongchao presented, it's going to be soon possible, and it is already possible, but soon a lot easier to build on Alephium. So, if you want to start building and you want support, please don't hesitate to contact us. And yeah, as you've seen, you can already pretty much make your own NFT platform. So go for it.
Thank you, Maud. And also for all of those who weren't there in the beginning, just a reminder that the team will be in Paris for the SCC from the 18th to the 21st of July. And Cheng will have a talk, and you're very welcome to reach out to us. Even if you don't have a ticket to the festival, just give us a shout out, and we'll figure a way to hook up.
And also, we'd be very happy if you tell us, guys, what you want, what you'd be interested in for the next tech talk, because we'd like to make that exercise a bit more frequent, or at least regular. So if you have ideas, you can always drop them in the channel suggestions, or here now, if you know what you want to talk about. Because we obviously heard about the layer 2 ideas, and now seems to move the discussion about NFTs.
So I'm going to read Monte's question out loud. As much as I love what you guys do here, the majority of us are probably not developers and just miners. Is there any plans to attract big developers, maybe from currently existing platforms onto Alephium?
I can take this one if you guys want. So right now we have, we are really in the process of building everything and documenting everything so that the development experience gets a lot easier and seamless on Alephium. Once we've reached a stage where we feel like those are really mature, we'll start doing hackathon. We have a few things planned also at ECC in Paris because that's a conference that is also mainly towards developers. So we have a few activities planned around there to increase awareness around Alephium to the development community.
Yeah. He sends a happy Pepe. Okay, Pepe. Cool.
Monte has one more.
One more. Excellent. Bring it on, Monte.
But then maybe also while he writes the question, I just thought, because now my dog stopped barking, I just thought of another thing. Obviously, we're also working into making our grant program a lot more easy, a lot more visible, but all of this will a little bit be synced together. So we'll have a grant program. We'll start also proactively publish bounty on specific topic we want people to work on. So those are iteration in progress, and all of it should kind of come together around the same time.
So I'm going to read his question, Monte's question. You guys mentioned earlier something about adding more chains onto the existing 16. Is that actually a thing, or did I misheard that it's possible to add more chains to boost the network?
Yes, it is possible, but it needs to be planned. As far as I understand, it can't be done dynamically. That's my understanding, but I could be wrong.
Sorry.
Yeah, go ahead.
I think so. We can scale up to 1,024 shard, which will be 32 groups. But I think to increase the number of chain, we require a network upgrade, which I think is what you were saying, Hongchao.
Exactly. Yeah. Exactly.
People are saying bye in the chat, so I think it's time to conclude this. Thank you very much for attending, everyone. It was nice to see your face for all those who put on your camera. Very cool. And like Vladimir said, please don't hesitate to tell us if there's anything you would like us to discuss for the next session. And as always, see you on the blockchain. All right.
Yeah.
Thank you, Hongchao. Thank you, everyone.
Have a great evening. See ya.
You too. Happy Midsummer. Bye-bye.
Bye.